Hi, everybody. So before we get started, I want to ask a couple quick questions. So how many of you guys are actually running containers currently in production? Awesome. How many of you are using ECS? Rad. OK. How about using Kubernetes? Very cool. OK. Anybody using DCOS? Awesome. OK. Welcome to GPSTEC304. This is shipping with Porpoise. It is a Kubernetes story. I'm also throwing in some other things in there to kind of feel out the water and kind of give you guys a brief introduction to some other tools that will help you guys continue to ship and deliver your applications. I am Chris Hine. I'm a partner solutions architect with AWS. And so I actually focus on working with all of our container partners. And so that's anything from orchestration partners to CI/CD partners to networking to runtimes, so Docker and CoreOS, all those guys. And yeah. So today, we're going to talk a little bit about DCOS. We're going to talk about a little bit of like background, why it's there, what it's good for, the technology behind it. Then we're going to talk about Kubernetes. Then we're going to talk about some Docker best practices. Some of these things you guys might know. Some of it might be new for you. Then we're going to talk about some continuous integration and continuous delivery. So that's going to be talking about like just a general overview as well as scanning for vulnerabilities and then doing deployments into Kubernetes. And then we'll talk about doing debugging and monitoring of Kubernetes applications as well as a little bit of DCOS. Just to toss it in there and have some more for us to talk about. And then last, I'll walk through a quick demo kind of wrapping everything together. So first thing is Mesosphere's DCOS. So Mesosphere's DCOS is actually built on top of an open source framework called Apache Mesos. Some of you guys might already know this, but it was basically started at AMP Lab in Berkeley by a guy named Ben Hinman and a couple other people. And their idea behind this was to create a distributed kernel. And they were using that to manage large fleets for HPC workloads. They designed this whole system so that they could actually build out, they could actually run their workloads efficiently and scale across those, as well as manage the thousands of servers that they needed to manage. So after they basically started developing it, they started talking about it. It eventually got accepted into the Apache frameworks. And it was later picked up by some pretty big name companies, Twitter, Apple, and Salesforce. They all kind of jumped on board because they realized that it's really hard to actually manage massive fleets. And I'm talking fleets larger than what you're seeing out of Kubernetes these days. And so Ben eventually, after kind of working on it for a little bit, he eventually left AMP Lab and moved on to work at Twitter. And so at Twitter, he actually ran their whole Mesos infrastructure. And after a few years of doing that, realized that he had a lot of industry knowledge in this whole space of doing Mesos. And he eventually decided that he was going to create a company to make it easier for you to run Mesos in production. And so that's where Mesosphere was born back in 2009. And the whole Apache project is open source. It's Apache 2 licensed. There we go. So for those of you that don't know this or are sort of new to containers or orchestration frameworks in general, there's a couple core pieces that I want to talk about today, especially with DCOS, because I find it really interesting what they're actually doing. So the first core concept that we want to talk about is the concept of a cluster. And the cluster in the guides of DCOS is similar to what you see on the right-hand side, but we're going to talk first about what's on the left-hand side. And so on the left-hand side, it's best, in my opinion at least, to explain this in something that you guys might have already experienced. So building web applications, for example. And so imagine you're co-located in a data center the 3 racks, imagine you have 3 blade servers in there, and you're running maybe a 3-tier Rails application. So you've got a database, you've got a load balancer, and you've got 3 Rails web applications. So it's really nice that you have like that small subset. It's really easy to manage. Potentially, you're doing it using Capistrano. And you have a server block defined in your config files. All you have to do is do cap production deploy, and you're up and running. You're good to go. Every time you want to redeploy, it's the same command. You can put that in a CI/CD pipeline. You don't really have to worry about it too much. So the big pitfall here is when you start to actually get into scale. And so scale, in this instance, let's talk about it at 100 times that scale. So now you're managing 300 servers. And you're basically going through and you're trying to still use those same exact primitives that you were using before. And everything falls apart. I mean, you probably all have experienced this, where you're going and you've built up a whole new infrastructure. You're trying to deploy into it using something like Capistrano. Maybe those 300 servers you're actually gathering by using the AWS CLI or a Ruby library in a Capistrano script that's grabbing every instance that you want to deploy to and dynamically putting it into that server block and then deploying. So the issue that you guys probably already know about here is you're taking a deployment that was 3 explicit commands on 3 servers, really easy, again, and you're amplifying that and making it 300 explicit commands. And those 300 explicit commands can be faulty, as every system that we build these days. And so think about it from the perspective of going and saying you deployed 250, you got it to successfully deploy 256 of those, to 256 of those servers. And you're left sitting there wondering, what happened to the rest of those 40 servers, or 40 plus servers? And you're like, okay, do I have to go manually debug this? How am I going to actually figure out what those are? Because the whole thing was dynamically generated. It doesn't leave you in a good place. You're left either trying to rerun the whole thing again and hoping it doesn't fail a second time. You're potentially left manually going through and figuring out what server it didn't actually deploy to. You're trying to redeploy it again. And realistically, that's where Mesosphere and DCOS and also Kubernetes comes into play and really changes that from something that's actually easy. It makes it easier to manage. And so it does that by very simply, at the most basic level, wrapping it in an API. Just putting an API on it and make that API do all the work for you. Now, that seems trivial if you put it at that perspective, but realistically, it's not. It requires a lot of things. And so the big thing that it actually requires, and you'll know this if you guys are working with any container orchestration, is a scheduler. So you basically need to actually have some kind of concept of a scheduler, something that can sit there on the servers that's going to gather all the CPU, the utilization, the memory, the GPUs, everything that you want to potentially provision based on. And so it's sitting there, and in Mesosphere's perspective, it's sitting on the master nodes, and it's gathering all that information, storing it into Zookeeper, and you're basically able to use that now as something that you can deploy against. So you're now saying, instead of where you were in Capistrano doing an imperative deployment, where you're like, I want to roll this out to all the servers, here's my list of servers, make it happen. You're now saying, I have this thing, and I want to deploy it. Make it happen for me. I don't want to do anything. I don't want to think about it. I just want that to go out. So we're talking about declarative resource offers, if you guys are familiar with that concept. And this can be anything from a long-running process, so it could be a web server, it could be a job that's processed based on some sort of event, so it could be Lambda triggered, it could be a Kafka job that's actually processing and doing some Spark machine learning, anything at all. And so in DCOS perspective, what that actually requires is that we have 3 tools to put that whole thing together. And so those 3 tools that are really critical to talk about when you actually are looking into these container orchestration frameworks, specifically DCOS, is Mesos, Zookeeper, and Marathon. And so if you're not familiar with those, Mesos that we already talked about is that distributed kernel. It allows you to send a an offer to it, and it will figure out where to run it. It's going to run all of the scheduling for you. And behind the scenes, it's integrating with Zookeeper. So it's a very common solution. You guys have probably worked with it before. It's necessary for doing HA deployments of things like Kafka, as well as Mesos in this perspective. And it's just a distributed key value store, and it's commonly used really for configuration management. And then you have Marathon. And so Marathon is a scheduler in itself that runs on top of Mesos. And you can think of this, if you're sysadmin or anything in that, or from the operations perspective, as an init or process management systemd per se for a distributed cluster like Mesos. Now, what's really cool about Mesos and why I find it really interesting is the whole ecosystem behind it. And so the whole ecosystem behind it gives you access to these very production-grade deployments of tools like the ones that you see up here. So Elasticsearch, Jenkins, Spark, Hadoop, Cassandra, things that are commonly difficult to run, especially in containers. So say, for instance, Cassandra, you need to figure out how you're actually, if you're in Kubernetes, you have to figure out how to do the stateful sets properly. Maybe you're trying to work with something like Portworx to actually keep that sane behind the scenes. Or Kafka, where you actually have to deal with virtual IPs at a different level, or Spark, where you really want to be able to scale that out efficiently. And so what Mesos did is it went to all these projects and kind of made them a core piece of that infrastructure. And it didn't just do that at a container level. It actually took it out and said, we don't need the container here. We're just going to run those things standalone. Now, Jenkins you can run as a container as well. Demo later, we'll talk about it in a container. And all these things you can. But at a lower level, you can drop it completely out of that and run it more efficiently, actually on the bare metal. So real quickly, just to talk about the architecture here. DCOS's architecture, when you break it down to blocks like this, it's really simple. It's really simple. And it looks very similar to what you're going to get out of Kubernetes. There's one other component in here that's the actual public slaves. That's depending on if you're actually using those. You don't have to. So realistically, what you have, especially with DCOS, is you have a CLI tool. So DCOS package install, DCOS app add to add things to Marathon, anything from that perspective, as well as you have a really nice management plane. Really nice, so you can actually deploy services from inside there. You can actually configure everything you want, and it gives you that all out of the box, and that runs on top of the masters. And then you have the slaves, which are basically going to run everything from your actual services within Marathon, or any of the actual tools that we just saw on the last slide. And then lower level, you're going to have the infrastructure. And as you have probably realized, as you dive into these frameworks, we're abstracting all of that away as much as possible. We're basically saying, don't worry about it. It's going to be it'll be there. We're going to work through that. We're going to work through that. So to move on, we also have Kubernetes. So some of you, as you guys already put up your hands, are already working with it. Kubernetes is kind of like the hot kid on the block these days. Everybody's really interested in it. So a little bit of background if you're not familiar with it. It was actually started at Google, and it was influenced by the Borg team. So a team of Joe Beda, Craig McLuckie, and Brendan Burns. Joe and Craig actually work for Heptio, who are a container partner of ours, as well as Brendan, who's now at Microsoft. And they basically built this they built this project based on their learnings from running containers at scale at Google. And their whole idea behind it was to ease the management from the bottom of the stack all the way up. So making everything extremely portable and making it beneficial from a small scale all the way up, which is one of the things that you don't find immediately with DCOS. DCOS is a little bit more work to get started with it, but you see the benefits as you grow larger and larger. You'll see massive, massive clusters with DCOS. So it's a strict container orchestrator. Right now, it has support for Cryo as a container runtime, Rocket, and Docker. There's other people out there that are working on new runtimes that are interesting and fun to play with. And again, this is Apache open source licensed, and it was donated to the CNCF as a project. So it's actually not a part of Google anymore. They still help out, but we've had a few production releases of Kubernetes that actually weren't managed by Google at this point, which is pretty neat. So they basically, they came to this to kind of dive a little bit deeper. They came into this whole container orchestration with similar guidelines to DCOS, but they took it from a different perspective. And they really wanted to focus on the management and updating of your applications and updating of the infrastructure and making sure that everything was easy and portable and you could actually take it, you could take any component out and really change it. So if you haven't worked with it, everything pretty much runs in a container. And you could swap out most of the components that are in there for anything else. So you'll see that we have customers and people just building random plugins and replacing internal components. So things like KubeNet, which is the current networking provider that's in the upstream, being replaced as we move forward by Core DNS that is much faster and more efficient than the actual KubeNet. So it's really interesting because you have a whole ecosystem of people that are really changing this. And so when you're actually thinking about it, because everything is really containers, when you update something, you're updating it just like you're updating your own applications. So there's not really a mind shift that you have to have with it, which is really nice and kind of allows you to move forward. So if you think back to that Rails application, throw that in a container, you're going to update that Rails application just like you're going to update any of the other components within it. Say, for instance, a networking plugin that you guys are using. It's just going to be a container. So tools and services and components that are really critical to the ecosystem of Kubernetes. So those things are etcd, the API server, and the scheduler. So if you haven't dove into these, etcd is a key value store similar to Zookeeper in its concepts, but it uses a raft-based consensus algorithm to actually keep everything in sync and uses a gossip protocol for all that. And then you have your API server. And so the API server is similar to what we talked about wrapping the DCOS clusters with. And in this concept, it's what you interface with when you're using Keepctl, or if you're deploying into like a dashboard into it, or any of your applications, you're really talking directly to that API server. And then behind the scenes, you have your scheduler. And the scheduler, just like DCOS, is sitting there and constantly spinning. And it's basically saying, OK, I know the stored state in etcd, and I see what we have currently running in production. How do those differ? And if they do differ, it actually will change that to always match what's in etcd, which is really interesting because it really goes towards the concepts of having a declarative infrastructure and an immutable infrastructure as well. So you can basically write a config file, you deploy it, it's going to make it happen. If you're going to change something, you have to go back to the config files. If you don't, or you can update it on the fly, but that's really an anti-pattern in this ecosystem. And so yeah, you're really just deploying a config file, and it works out what it needs to. So the benefits that you're going to get out of something like Kubernetes is really the developer tools and the ecosystem. As I was saying, it's a massive, massive ecosystem right now, and it's constantly changing and constantly growing. You have basically a wealth of people right now that are all gung-ho on it. They've been running applications in it in production. Some people are new to it, and everybody's contributing, which is really cool. The open source community behind it is great. To deploy things on AWS, for example, there you can deploy it using COPS, or there's a tool called KubeADM, or there's another tool called Kubicorn, and they're all being created by these people that find these issues and realize, like, okay, I've got an idea. I'm gonna work to try and actually solve that, which is great. And as we move forward, that's sort of starting to come together into a really fast-moving ecosystem. And it all builds on top of that modular core. So being able to plug and play. I don't want to actually run a KubeNet, I want to run core DNS. Or, for example, I want to do policy management of my network, so I could go and actually look into something like Calico to help out from that perspective. Or I want to be able to do CI/CD on there. You have a number of partners that can actually go and deploy a continuous integration framework or workflow management tool on top of that are pulling from the past of what we've all learned from managing bare metal servers and running Jenkins servers and doing all of that on our own, and basically being like, okay, now we have this thing that can automate everything and really make it really efficient. And then the last piece is that it's extremely portable. So started at Google. Obviously, there's people at Google behind it. We have a wealth of people that are actually building out enterprise orchestrators for it, so things like OpenShift to actually help you deploy your applications better, and they're building in tools to make the CI/CD part better. You also have companies like CoreOS who make Tectonic, who really strive on being an upstream-based but enterprise-supported Kubernetes deployment. And then you have, all the open source projects that will help you deploy as well. And so you can run this on-prem, in the cloud, anywhere you really want to. So architecture-wise, if you break it down to the core basics, this is it. You basically have a CLI. If you deploy the dashboard, you've got a dashboard on there. If you don't need that. You just basically have a Swagger API that you're interfacing with. You've got your Kubernetes masters, and that's where you're running the API server and etcd, unless you abstract that out. Then you've got your infrastructure running below, and you've got your worker nodes that are actually doing all the work. And then you've got your services and tasks and jobs, anything you actually want to deploy on top of that. Pods is what that actually should say. So that's all well and good. That's kind of the basics overview. We'll talk more about those two things as we go into the demo. Now I wanted to shift a little bit and kind of just dive into some Docker. So some Docker best practices. These are things that I think one of the things that I really wanted you guys to get out of this is a wealth of new tools and functionality that you can actually play with to help make your guys' applications better. And so best practices with Docker, I think, really fits well into that. So things like planning for cacheability. So if you've worked with Docker very much or not at all, you probably won't be familiar with this. But in essence, when you define a Docker file, you're defining line by line by line by line what you want it to do and how you want it to be built. And what that's actually doing under the hood is creating hash-based layers of each one of those commands. And so when you actually think about it from that level, you can actually take your Docker files and actually plan them in a different perspective. So instead of being something like a container where you're starting from Ubuntu and you're throwing in a run command just to install or just to add in some packages, and then another run command to do something else, and then another run command to do something else. All of those things end up being individual layers that can be reusable, but every time you layer on top of them, it makes it harder and harder to actually do that, because you need to keep everything above the stack the same. And so in this example, I chose the easiest way to do it, because Go is really easy to build a Docker file for. But in this instance, you basically have the Golang Alpine image. It's going to be super easy. It's going to be the exact, you're going to be able to reuse that, which means once it pulls it down, it's going to actually not have to ever cache or pull that image down again, as long as the hash stays the same. The work directory, for example, you have nothing in it. So again, reusable. then you start to add in your application code. And this is where you start to get to new hashes. So when you were to create your second Go application, those first 2 lines, you'd never have to re-download again, which is pretty awesome. And you can actually do this with any sort of thing, or any Docker file that you're actually building. So this could be a Ruby-based Alpine image. This could be anything you want, Debian, Fedora, so on and so forth. But when you're thinking about it from this perspective, you really want to change that thought process that you might have had from deploying, say, just bare metal, or not bare metal, just standard EC2 instances. You don't really always want to start from Ubuntu. You don't have to. There's no reason to. In the next slide, we'll actually talk about even taking this container and making it even better, and using newer functionality to trim that down. Because this cacheability is nice, but the size actually does matter when you really get to production systems. Because every time you add a gig Docker file to your actual orchestrator, you're having to download that every single time, or at least the layers that change. And you're basically wasting your resources. If you can, always try and trim these down to as much as as slim as you possibly can. And so that's where we're going to talk about multi-stage builds. So if you guys aren't familiar with this, Docker released this back in March of this year. And so it's a really nice thing where you can actually now, where you might have used multiple Docker files, maybe you had dockerfile.build and then dockerfile.prod, you can actually do a whole trimmed down container in a single file. So in your single Docker file, you're actually going from the Alpine base, and you're setting it as an actual flag, as like in this instance, as a build flag. And so this is going to be something like a 300 meg file, or a container that you're pulling down. It's got all the build tools you need to actually run the container, or to actually build the Go application. You're going to add your source code into it. You're going to run it, or you're going to build it, sorry, into a binary. And then you don't have to have the line there, but I put the line break there just to kind of break it apart. You'll notice we go from again. And so that from again is basically saying, hey, I want to start from scratch. I want to start over. And so I'm going to pull from Alpine, which is like, I think, like a 4 megabyte container, which is fantastic. And I'm going to add a work directory. You technically could do this just on root, but I usually will do that anyways. And then you're going to copy from the actual build container. So whatever my artifact was that I actually exported from that the first part of the file. And I'm going to add that in, and then I'm going to add an entry point, and there's my container. And what's cool about this is it actually builds down to whatever the last image is. So the first part, you still have all those layers. You've already done all that work, so you can continue to use the caching that we just talked about. But you now have a 4 to 6 megabyte Docker container that just runs your Go application. In the past couple jobs, this has been something that I've loved doing. It's basically going and optimizing to the nth degree the size of these things to help speed up the actual deployments. Yeah, so it's really cool. So you can do this with anything that's like a compiled language. So Java is another good place, Scala, anything in that perspective, where you could pull from something and you could run it on Alpine and trim down your containers to something nice and easy. So that's all well and good. What about other things? What else can we actually do to make these more efficient? So we can do things like adding a Dockerignore. You find that I still find that I find a lot of projects that actually aren't doing this. And you'll find Git files still in your actual Docker container. You'll find temp files. You'll find all these things that are unnecessary for production runtime. You don't need all of that. Especially don't need your .env file from your dev environment. Why would you do that? You don't want to actually have more risk for leaks of data. And again, you're speeding up deployment because you're trimming down that container into something that's nice and tidy, easy to deploy, and it's easy for your CI pipelines to actually work with. And what's really cool is when you get into what we're going to talk about next with continuous integration, this really helps out because you can do things like with Jenkins, for example, you can run it on top of DCOS, which I'll show in a demo, and have it pull down a completely new environment, boot a container, run all of your jobs in a container, and then have that shut down and you have nothing left. So every single time, if you're, as long as you're continuing to plan for that cacheability and plan for the speed increases, you're not downloading all of these new things every single time. So continuous integration and deployment. You guys are probably familiar with this. It's been around for a long time at this point. But just a brief overview. So what this entails. So this entails things like version control, a little bit. Branching, code review, any sort of thing from that perspective is sort of hand-wavy included in it. It's critical to make this happen, but really the other two tiers are the important parts. So compiling code, running a unit test, running static analysis, and packaging your applications, doing integration tests, anything from that perspective, load tests, so on and so forth. And one of the things that I find that the customers that I work with are still trying to figure out is how to go from just running a container that you're running maybe your unit test in. That's not that hard. You're kind of just pulling from Docker, and you're going to run your actual, say, RSpec if you're in Ruby, or if you're in Ruby, or maybe you're running Go test in your container, and you're good to go. And your static analysis, most likely that's going to be on the code side of things. Less so much on that, but the security side of things. So security within containers is something that people are sort of still trying to bridge that concept. And so one of the partners that I work with that has a really cool solution for it, I'm going to talk about next, which is TwistLock. And so basically they actually have a really cool tool. And in this instance, my multi-stage build is going through and saying, I want to build this container. And then I have two stages that are a scan and a publish. And so what we're actually doing under the hood of these things is we're scanning the actual container, so where it's from, the actual base image, anything that goes along with that, and scanning for vulnerabilities. CVEs, they manage a massive list of these things and keep it up to date. And you can build this into your CI pipeline so that in, say, for instance, Jenkins, as we're talking about here, you'll have a graph that will actually show you what's going on and how that's degrading. And you can further integrate this into your networking solutions within Kubernetes, within ECS, within DCOS, so that you can do evictions. So if you find that your container actually goes through this, or it's consistently running in the background in Jenkins, you can set it that way. So it finds a new vulnerability. It's actually going to kick the container out of production or notify you. You can do a lot of different functionality with that, which is great for workloads that need compliance needs. So anything that's like HIPAA related, SOX related, being able to actually get that granular notification, but also down to just even your own web applications. Like, let's start to make these things more secure. Yeah, so security, it's obviously important. I would highly recommend starting to look into that as you kind of keep diving deeper and deeper and deeper into your containerized workloads. And then the last thing around continuous integration and deployment is deploying. And here you can use, this is one of those simple things in a deploy script using Jenkins, just to throw it out there. Not super complicated, especially in the Kubernetes world. Keepctl apply. You don't have to worry about what config files they are, as long as you're managing or you're updating whatever version you have. It's declarative. Everything's managed through Git. You're good to go. Now that you've actually gone through that whole flow, you basically have your orchestration. You figured out how to actually do your containers in a proper way. You're able to keep them trimmed down. You're not exposing any vulnerabilities through your env files, anything like that. And you deployed it. Now what? Now you basically have to go through and figure out what you're going to actually do to debug and monitor these things. So in this instance, I'm going to be specifically talking about Weave and WeaveNet and WeaveScope. But there's a number of really good tools out there for this. So things like Datadog to actually do management or visualization of your container workloads. You could do this, a wealth of tools out there. Instana. But specifically, I find that Weave has a really interesting take on it because they give you this a debugging console that's really great for actually doing like staging and dev workloads in an actual environment that is like production. So under the hood, you're basically, to actually get all this stuff running, you run a CNI plugin on Kubernetes. You can also run this in DCOS, and it's deployed via daemon set. And you can actually have, there's RBAC configurations or role-based authentication configurations that go along with it to help make that actually possible. And what it does is, under the hood, it transparently makes, it allows your containers to connect securely. It's a really great tool. You can add in things like mutual TLS through the actual containers. And then on top of that, you add in scope, or what I'm going to talk about during the demo, which is just the managed version of this, which is cloud, which basically allows you to take all of that traffic that you are already pushing through WeaveNet and visualize that into a hierarchical perspective and being able to dive into an individual container and say, okay, what's actually going on? I want to log that, or I even want to shell in and debug something because there is some issue on our system. And I think that is, yeah. So I'm going to switch over to a quick demo. Computer locked. Give me 1 second. Cool. Can everybody see that, or does it need to be bigger? Bigger? OK. Cool. So, better? Cool. All right. So first thing, if you guys aren't experienced, if you haven't worked with this, so I wanted to kind of give you the high level, hey, this is DCOS that we talked about early on. And the reason why I brought that up is because I find that it's a really interesting play that they're having where they brought back Kubernetes. So they brought back Kubernetes on top of Mesos, so you actually can do co-location of your data services, so your Cassandra, your Kafka, your Spark, all of those things. You don't actually have to go and do those things in containers on top of Kubernetes. You could do them actually on DCOS. And you can run that just like I'm running Jenkins right next to it. And you can then deploy your applications into Kubernetes. This is still in beta for right now. I think they're expecting to release that in next year, I think early on next year, if I recall correctly. But it's still something that's interesting to play with and kind of gets you moving forward, and it gets you an upstream version of Kubernetes that you can play with and a really easy to deploy perspective. So what I've actually done here is I basically have DCOS. I also have Jenkins. So Jenkins using pipeline jobs connected through an organization. In this instance, I'm actually talking through my own organization. And then I have a handful of actual projects that go along with this. So this is my microservice application that does an API for giving motocross times and lap times and tracks that you can go to. And then it has a web app that goes along with it. Very simple. But it gives you the perspective to be able to look into things like networking, and because it uses the lap times and the tracks APIs to actually feed the gateway, which will add in things like rate limiting and filtering of the actual components. And then the web app does the visualization and still connecting through. So the demo that I really wanted to talk about here is actually how those two things work and how they push together. So I'm doing two things. So at its current perspective, this is the web app. Don't judge me. It's quick and easy just to get something together. Behind the scenes, that's connecting to an API to grab the tracks down the left-hand side, and then all the actual lap time data for all the riders on the right-hand side. And then here's the gateway that goes along with it. It's just a HAL JSON endpoint that actually puts together everything for you to visualize. So what I really wanted to do actually today is go through and talk about two of the components. So multi-stage builds. So the original web application is actually this Docker file. This Docker file that's right here. And so you'll notice it's from Ruby. I'll highlight that. It's from Ruby. It adds in an environment variable for the app path and the home path, and it makes a directory, and then it sets that as a work directory. And you're doing interesting things like we talked about before, planning for cacheability by adding in the gem file before you're actually adding in the application code. And this goes down to being able to say things like running bundle install without actually having the application code, because realistically, you don't always need to run your package management after you update just your application code. Your dependencies don't always change. So being able to add that in ahead of time, cache those, and then being able to add in your application code so that anytime you rebuild this container, potentially all it needs to do is do that copy step and your command step, which speeds things up drastically. Now, what I'm actually going to do here is defer completely away from this, because we all know that, well, maybe we don't all know. In this instance, I'm tired of Ruby, and I really want to switch over to Go because it's much more efficient. And so I wrote a very simple multi-stage Docker file that is on your left-hand side. And so that's doing exactly like what we had in the actual slide deck. So this is pulling from the Alpine Linux, or the Golang Alpine Linux, and setting it as a build container. You're adding in your source, setting that as your work directory. You're going through and actually building that. And then you're then starting again from that base image, that 4 megabyte image, and saying, OK, I'm going to add in this index.html just to actually prove out adding something in there. And then I'm going to copy over that artifact and deploy and set that as an entry point. So what I have here is a new branch that has all this code. I'm actually going to push this up, and then once that actually pushes, as long as the internet behaves on me, we now have that in here. And I'm actually going to go and create a new pull request. And this is my Golang rewrite. Very simple. That's all I did. Took out a bunch of stuff. And I'm going to view pull request. Why did that do that? Cool. Create pull request. So I'm going to go create the pull request. Now, if I dive back into Jenkins in a second, after this continues to loop behind the scenes, and for sake of making sure that it actually processes, I'm going to kick that off. So that's going to go scan. If you guys haven't worked with the organization pipeline build in Jenkins, it's pretty nice. You can actually basically hook it up so that you can scan all of your applications, and it'll look for things like Jenkins files. You can exclude whatever you want to actually exclude from those. And so as you can see, it scanned all of my projects, so those 4, and it found pull request 7 right here. And I'll jump over into this view. I find it a little bit nicer. And we now have pull request 7. And so behind the scenes, what is really interesting and why I added DCOS in here is because of this ability to do things like take Jenkins, and behind the scenes, this is actually booting another instance of Jenkins, an agent instance on DCOS. As you can see, it just shifted the status over. Yep, there you go. Just shifted the status over to an unknown status for that second container. And it's fully running that whole Jenkins file. And I'll actually show you that as well. So it's running this whole Jenkins file. There. This Jenkins file. So all it's doing is checking out code. I set a couple variables up at the top. And then it's going to build that. It's going to push it to Docker Hub, and it's going to use my credentials that I have stored in Jenkins. It's going to test some code, which I don't have unit tests written here because I'm not a good developer, apparently. And then it's going to scan the container using TwistLock. It's going to publish that as well. so that it can continue to scan and look for things. And then all I'm going to do is actually use sed to add the new version number into that based on the actual short commit version. And then I'm going to do kubectl apply. Because all I really want to do is I want to take this and I want to overlay everything that I already have in production. So once that goes through, you can watch that cycle through. If you haven't, the new blue theme as well is really nice for Jenkins. Kind of gives you like a circle CI sort of perspective into how it actually how it's processing the individual steps in the pipelines. And it's scanning. Publishing. And after that goes through, I hope. Cool. So now that completed, and I'm going to give it a second. So as of right now, with Kubernetes on top of DCOS being in beta, there's still a couple kinks getting worked out. So things like connecting into the cloud provider flag, if you're familiar with Kubernetes, and being able to actually boot up load balancer ELBs out of the box, or NLBs when that comes out. So that stuff is still being added into it. So as of right now, I have an ELB that's manually just pulling against all the instances to actually get that list. And in a second, this should actually change to hello GPS. And so that's that. So that's kind of OK, let's actually put together that CI/CD pipeline. And then we're going to also throw in to Weave Cloud as well to kind of give you guys the view of what we're actually doing. And so this is just Weave Cloud connected to Kubernetes. And so you can see I have 3 or 4 actual pods. And in each one of those pods, I have 3 replicas of each thing. And so, as you saw before, I had my gateway, I have my lap times. And what's really nice here is you can actually dive into these individual things. You can actually go and see what I did here. So every single application in this perspective, I tried to write using a different language to kind of show that whole microservice perspective. So in the gateway, it's a Node.js project that you can see using, actually I should make this bigger. And it's using npm start to actually boot that up. It's been running for 2 hours and 6 minutes. You can see the actual PIDs, the processes that are actually going on. This thing might not work through the network, but this is actually a console that you can actually dive into, and you can do things like PS. You could list everything that's actually going on, list the files that are in there, make sure everything looks right, which is really nice for when you're actually doing like staging and testing to actually. Yeah, I don't think that's actually going to connect. For doing actual like testing of your applications before you roll that out to production. And that is pretty much my demo. We have 12 minutes for questions. There's 2 mics. If you guys have questions, please walk over to those, because we're recording this whole thing. So. Cool. All right. Yeah. Is that mic on?
Hello, hello.
Hey.
Good. Great demo. Can you make available, how you built it? The version numbers and all the integrations and stuff like that. It's a real good way of showing how it's all demoed. So.
Yeah, absolutely. So I'm going to try and put together this and actually release it on GitHub. I need to work through a couple of things to actually get that possible, but I will. I will absolutely do that after this. So.
I'm more curious about how do you manage a Kubernetes cluster, right, with kubectl with multiple members, right? So you have service accounts and actual admin account, which is created at the beginning.
Yep.
So is there is there a best practice or a additional tool that you use for like large team, like I have 20 developers or DevOps guys that needs to manage that cluster, for example.
Have you dove into using like the RBAC configurations and anything like that? Because you can actually do role-based authentication for all of your actual users, as well as you can set up namespaces for teams or applications, however you actually want to structure that. It sort of depends on how you're actually building your applications and your team structure.
I mean, you can create the namespaces, but you still have, like, when initially created, I guess it's similar
the image,
to...
the actual first user that you actually like created, that admin user.
Yeah, like it's like AWS root account, I guess.
Yeah, and so treat that like a root account for like something like AWS. So keep that guarded. You don't want to share that with it. You want to limit the amount of people that you're actually sharing that with. And then you're going to give guarded access through things like resource quotas to other team members that you're actually working with.
And also, is there any such tool that with the, like, I know the, like, kubeadmin, I guess you can use that via SSH tunneling, but is there such open source tool like how Weave-Cloud works right now?
So Weave-Cloud actually, behind the scenes, there's another tool called Weave-Scope, which is, it's not everything that's not all the functionality of Weave-Cloud, but it gives you this perspective. I actually have it running on DCOS that I can pull up. So this is Weave-Scope. It looks a little different in DCOS because it's pulling up uncontained containers. But this is similar functionality. You can dive into these things. And this is an open source project, just like the WeaveNet. It goes along with it.
Thanks a lot.
Yeah. Yeah.
Similar question to the previous person. In your example, when you use Keepctl, is that actually state on the file system that you're using to authenticate to the Kubernetes API, or is it injected via the environment? How is that managed in your example? Yeah,
that's a great question. So in this example, because I'm running on top of DCOS, it's completely guarded already. And so I'm actually connecting directly through Mesos's DNS to actually route directly to it. What I didn't show is to actually make this possible, I actually have a GitHub. What is it? It is this. So DCOS has a built-in agent that you can run, or that it will actually use. And what I did is I modified this agent specifically for being able to add in Keepctl. It's an Alpine Linux distribution, so it's really lightweight. And what I did is basically just add in Keepctl. And just to connect to DCOS, that's all you need to have once you're inside the network. But other than that, they guard it completely. So you don't actually have to deal with any of the credentials or anything like that, which is kind of nice behind the scenes. So, but that, as you can imagine, API server dash insecure Kubernetes L4 LB, like that's not publicly accessible at all, and it's 100% guarded by the Mesos networking. So I have that benefit.
Gotcha. So that's actually baked into the container via this Docker file.
Yep. Cool. Fantastic. Well, thanks, everybody.